So here we have another triangle, and we're asked to find the length of side A. Now it's not a right angled triangle, so we can't use Pythagoras' theorem, and we can't use basic trigonometry either, SOHCAHTOA. But not to worry, we know what to do now. Start by making sure that everything is properly labelled, so I'm just going to write in little b there, and call that side little c. Then start off by writing down all of the angles and all of the sides, and just taking a look at what we've got. Side A is 65 degrees. We don't know angle A, sorry. We don't know angle B or angle C yet. Side A we don't know, that's the one we have to find. We know that side B is 4.9. We know that side C is 3.7. Now we run into a problem. To use the sine rule, we need a matching pair. We need to have an angle and a side for one of these letters, and we don't have that. But not to worry, we've got one last trigonometry trick up our sleeves. This one's called the cosine rule. It's not too difficult. It starts off the same way as with the sine rule. We take our triangle and we label all of the sides with little letters A, B and C. And then just like before, we make sure that the opposite angles are labelled with big capital letters. And this one, opposite side C, is going to be big angle C. Now the cosine rule isn't too difficult to remember because it starts off exactly the same as Pythagoras' theorem. A squared is equal to B squared plus C squared. So that's the same as Pythagoras' theorem. With Pythagoras' theorem we said the hypotenuse, if you square it, that'll be the same as the two short sides if you square them and you add them together. But because this isn't a right angled triangle, we have to compensate for that. And so we just need to take away a little bit off the end. So we take away 2 times by little side B again, and side C. And then this is where the cos comes in. Times by cos of angle A. And that's it. That's all there is to the cosine rule. We'll now be able to use this to find that missing side in our first triangle. So returning to our original problem, we can't use the sine rule, so I'm going to use the cosine rule instead. A squared is B squared plus C squared, and then we just need to tack that little bit on the end as well. Take away 2BC cos A. Right, now just like with the sine rule, we just need to substitute in what we've got and then crunch the numbers. So side B is 4.9 squared. We'll add 3.7 squared. Take away 2 times 4.9 times 3.7 times cos of 65. Ran out of space a little bit there. But that's it. The hard work's been done. This is now just sticking numbers into your calculator, and you are always giving a calculator to solve this kind of problem. So 4.9 squared is 24.01. 3.7 squared is 13.69. And we're going to take away 2 times 24.9 times 3.7, which is 36.26. Times by cos of 65, which is 0.4 should be 23. Next line down, let's work out some more of those numbers. 24.01 plus 13.69 is 37.7. I'm going to take away 36.26 times by 0.423, which is 15.34. Nearly there. 37.7, take away 15.34 is 22.36. Now, just like with Pythagoras' theorem, that gives me a squared, but it doesn't give me the length of side A yet. In order to find that, we need to find the square root of 22.36. So A is equal to the square root of 22.36, which is 4.73 to 3 significant figures. Now that we have that, we can write it into our diagram. We can write it back in up here in case we need it for another part of the problem. With the calculators we have in school, you could actually just put all of this line into the calculator in one go, which would take you straight to this line here. Save you having to write out these two lines, which does have the benefit of making sure your numbers are accurate because you're not constantly rounding numbers at each stage of your working. And it also helps to make sure you don't make any accidental mistakes when you're writing down numbers or when you're putting them back into the calculator. So long as you have this line here, which shows you've substituted everything into the equation correctly, and then you're careful when you use your calculator, there's nothing wrong with skipping over these two lines and going straight to this one.